stack, you should have to confirm whether the stack is overflow or not. So for this, there is a condition to check whether stack is full or not. Push, in push function, you should have to check if toss is equal to max size minus 1. If this condition is true, if this condition is true, then print a stack is overflow. Else, if this condition is not true, that is, there is some space to insert new element. Then suppose here only one space and toss is equal to max less than max size minus 1. Then go to the else statement, increment toss by 1, that is, uh, toss is equal to toss plus 1, and stack of toss is equal to new element which you want to insert. Okay, this is the push operation. So in push operation, insertion of an element into stack is called push operation. If you want to insert an element into the stack, you must have to check whether stack is full or full of elements. That is, you have to check the overflow condition. This condition satisfies if stack is of size max stack is equal to n. That is, if stack is declared of size n and is full of n elements, then max stack is equal to n. And if this condition occurs, then you could not insert new element into the stack, and then the situation is called is overflow, and then we have to return back. But if this condition is not occur, then you can insert an element into the stack, and so it is called as push operation. We'll see push algorithm. So let us consider a stack of max size is an array for implementing the stack. Then first step, you should have to check the toss is equal to max size minus 1. If s, then go to step 2. What is the step 2? Print overflow and go to step 5. That is 5. Step 5 is exit. If this condition is not true, that is it becomes as a false, then go to step 3. Step 3 is toss is equal to toss plus 1, increment toss by 1, set tag toss is equal to element, that is insert element in new toss position. This is the push operation. See this slide carefully. The next slide, code for push function, void push. In that, declared as a local variable element, then check toss is equal to max size minus 1, then print stack is overflow, otherwise that is else statement. Printf, enter the element to be inserted, scanf percentage d and element. So increment toss by 1, that is toss is equal to toss plus 1, then stack toss is equal to element. This is the code for push function. Then next slide, that is pop operation. So deletion of an element from stack is called pop operation. If you want to delete an element from the stack, you must have to check whether there are the elements in the stack to be deleted. That is, you have to check underflow condition. This condition satisfies if stack of this size max stack is equal to 0, that is toss is less than 0. If this condition occurs, then you should you could not delete an element from the stack because there are no elements present in the stack, and this situation is called underflow. But if this condition is not occur, then we can delete an element from the stack and so called as pop operation. First we will see as a figure. Here this is a stack of size 5, and I want to delete element from this stack. Here toss is equal to -1. When this condition occurs, when there are no elements in the stack, that is stack is empty, then toss is equal to -1. And if toss is equal to -1, then stack is underflow. You cannot delete elements from the stack. So you should have to check first whether toss is equal to -1. So if first step, if toss is equal to -1, then print a stack is underflow. Then third step, else, then decrement toss by 1. Toss is equal to toss -1. So before that, element is equal to stack toss. Stack is array of this stack. Then else element is equal to stack toss. Then toss is equal to toss -1. Then print percentage d element is deleted. Then element, then stop. Okay, this is the algorithm for pop operation. We'll see the slide. Let a stack max size in array for implementing the stack. If toss is less than 0, that is toss is equal to -1. If this condition is true, then go to step 2. Then step 2 is print stack is under flow, and go to step 5. If this condition is not true, then go to step 3, that is a decrement toss by 1. Toss is equal to toss -1. Return the deleted element from the stack and stop. This is the pop operation. Then code for pop operation. Void pop integer element. If toss is equal to -1, printf stack is under flow, else element is equal to stack toss, and toss is equal to toss -1. Print deleted element is equal to %d, then element. See the code carefully. Then next operation is traversal, that is a display operation. Display of a stack element is called as a traversing operation. If you want to display an element from the stack, you must have to check there are the elements in the stack we display. That is, you should have to check underflow condition. If this condition satisfies, that is toss is equal to -1, then you cannot display the elements from the stack, because there are no elements present in the stack, and this situation is called as underflow. But if this condition is not occur, then you can display an element from the stack, and this is called as a traversal operation. We see the algorithm for displaying elements from the stack. So first you should have to check toss is equal to -1. If this condition is true, then go to step 2. Step 2 is stack is underflow, and go to step 5. And step 5 is exit. See, if a toss is equal to -1, if toss is equal to -1, if this condition is true, then print stack is underflow and stop. If toss is equal to -1 is false, then display element one by one and stop. This is algorithm for display operation. See the code for display operation. First check toss is equal to -1, then print stack is underflow. Otherwise, for I equal to toss, I greater than equal to 0, I minus minus, then print the element position and the element. See this see this code carefully. Then next is a program for stack using array. So the first include the files stdio.h for printf, scanf, push, pop, then conio.h, then stdlib.h, standard library file for the exit function. -1, then declare stack size is suppose 5. Then declare the functions push, pop, display. Then go to the main function. Then go to main function. In main function, we have declared two variables, character and a is equal to 1. And have used do while function, do while loop for executing this stack using break do. Then here four operations: push, pop, display, and exit. One dot push, two dot pop, three dot display, and exit. Then print and choice. Then correct scanf, percentage D and ch. Then switch a ch. Then in switch case statement, there are four cases we have written. Case 1 for push operation, then break. Case 2 for pop operation, then break. Case 3 for display, then break. Case 4 for exit and then break. Last is default operation. Enter operation, correct operation. After switch statement, print, do you want to continue? Then scanf percentage D and A. While A is equal to 1, if this condition becomes true, then again go to do statement. Suppose you have entered a choice first, push, this push operation, then go to the definition of push operation. So while push int element, if toss is equal to max size -1, then print a stack is overflow, and otherwise enter element to be inserted, scanf percentage D and element stack, then stack toss is equal to suppose even operation is off, then check a stack is underflow or not, that is toss is equal to 1. If this condition is true, stack goes to the underflow situation. If this condition becomes false, then you can delay the elements by decrementing toss by 1. Then suppose you have selected third option, that is a display. go to the display definition. First, you have to check whether stack is overflow or not. If stack is underflow, then you cannot display, you cannot display the elements. If stack is underflow, you cannot display the elements. That is toss toss is equal to -1. If this condition is not true, then display the elements one by one from the stack. This is the code for stack using array. See the code once again. See your code is written as your initially your code is written initially toss is equal to -1, then declared as a max size equal to 5, integer stack max size. Then we have declared the functions push, pop, display. Function we have declared the variable character ch, a is equal to 1. Then in we have written printf statement like this. One push, two dot pop, three dot display, four dot exit. Then you will get enter your option. Suppose you have selected the option as 3. Option 3 is display. So go to the third third case. Third case is display. So go to the definition of display. Here is the definition of the display. You should have to check stack is underflow or not. Suppose here
Sir, screen is not visible.
stack initially toss is equal to -1.
Hello, sir.
Hello?
Screen is not visible, sir. Screen is not visible, sir.
1 minute. Now screen is visible.
Yes, sir.
See, initially we have declared that toss is equal to -1, and we have selected the case number 3 as a display operation. So go to the definition of display operation. First check toss is equal to -1. If this condition is true, then you will get output as a stack is underflow. So go to the again statement. Here after executing this display, go that is break this switch statement, and the question is asked as do you continue. If given answer as a 1, then if into this condition 1 is equal 1, if this is a true, then step again you will display. There are again 4 options: 1 dot push, 2 dot pop, 3 dot display, 4 dot exit. Enter your option. Now you have a selected option as a 2, that is go to case a 2, that is a pop operation. Go to the definition of this pop function. So here in pop function you should have to check whether toss is equal to -1. If this condition occurs true, then you will get output as stack is underflow. Then go to the case second, then break this switch case statement, then go out of the huh? Now it is visible. So your question is, do you want to continue? You have entered, suppose A is 1, then check 1 is equal to 1, then go again to check, you 2 dot and 4 dot exit, then enter your choice. Suppose now you have selected a choice as 1, so go to case 1. Case 1 is for push statement, push function. So go to the definition of push function, that is check toss is equal to max size minus 1. That is 5 minus 1, that is 4. This condition becomes false. So go to the else statement. First, first you should have to check toss is equal to max minus 1. Here max is 5. So toss is equal to 5 minus 1, that is 4. This condition becomes false because here we have declared a toss is equal to minus 1. So the else statement, enter the element to be inserted, then insert element and increment 1. And then add toss is program by Turbo C. Here code is written. We'll execute the code one by one. That is step-by-step format. Execution of any program starts from main function. Go, go to the main function. Then put declaration of these variables. Then enter in do while loop. You will get first output as 1 dot push, 2 dot pop, 3 dot display, 4 dot exit. Then enter your choice. Then you have entered like this. Suppose you entered choice 3. Then go to the choice 3 as a display. Then go to the definition of display function. Then after executing this function, go to the out of switch and you will get this output. Enter the specific. If you want to continue, press 1. Then here you have selected choice 3. You will get output is stack is underflow because initially there is no any element present in the stack. That's why we have received the output as stack is underflow. Do you want to continue? See here, question is asked as do you want to continue? Your question is asked as do you want to continue? If I press 1, then go to the while condition for checking this condition is true or not. If this condition is true, then go to again do loop. Then you will get again 4 options: 1 dot push, 2 dot pop, 3 dot display, and 4 dot exit. Enter your choice. Now I have selected choice as 2. Then go to the switch statement. Then go to the case second, that is pop. That is go to the pop function, definition of pop function. Then execution of this pop function, you will get a question: do you want to continue? Then here scanf, enter your answer. You have selected choice 2, that is pop function, but initially there are no elements present in the stack, so stack is underflow. Do you want to continue? Yes, I want to continue. I entered 1. Then again go to the do while loop. You will get again 4 options. Then enter your choice. Suppose I have entered as a 1, so go to the switch case statement, case first, push operation, and you will get element to be inserted. Suppose I have inserted the element as a 5. Then question is asked: do you want to continue? Then S, again do loop, enter. Suppose my choice is 1. Enter element I have entered as a 7. Do you want to continue? Yes, I want to continue. Insert elements. Suppose I have inserted element as a 9. Do you want to continue? Yes. Enter your choice. Suppose I have selected choice is 3. I want to display elements. Go to the choice 3, that is case 3. So you will get the output as first at 0th position you have insert 5. At first position you have inserted element as 7. At second position you have inserted element is 9. So do you want to continue? Yes. Insert your choice. I have selected choice is 2. Go to the definition of case second. Here selected choice is 9. Selected choice is 2 and deleted element is 9. So it deletes the topmost elements. Okay, we'll see. There are 4 options. Enter your choice. Suppose I have selected a 3. So initially there are no elements in the stack. So you get answer stack is underflow. Do you want to continue? Yes. Then again you have selected choice 2. So there are no elements present in the stack. So for deletion, so stack is underflow. Then do you want to continue? 1. Then enter element. Suppose I have entered element as 56. Then do you want to continue? 1. Then selected choice is 1. Enter the element. Suppose I have inserted element 57. Then do you want to continue? 1. Then select choice, that is 1. Is insert element. Suppose 59 I have inserted. Then do you want to continue? Yes. Select choice. I have selected choice is suppose 3. 3 is a display which displays the elements as at 0th position 56, first position 57, second position as 59. Suppose I want to delete the element, that is do the pop operation. So do you want to continue? 1. Then enter your choice. Selected choice as a 2, pop operation. So you will get a statement deleted element 59 which is recently inserted in the stack. So do you want to continue? Yes. I want to display elements. So select choice 3. Then see, this is the previous and this is now. Okay, this is the program code for stack using array. Suppose stack becomes overflow, then how can we insert the elements in the stack? My choice is first, that is push operation. Insert element 95. Again I want to continue. Then select choice. Then insert element 45. I want to continue. My choice is 1. Insert element suppose 54. Again I want to continue. My choice is 1. Here I will get the option as stack is overflow. I want to display elements. We have declared a stack size is 5. Arrays, so there are 0 to 4 elements. Max is -1, that is 5 minus 1, that is 4th position is the topmost position. So this becomes 4. Suppose I want to again insert element. Here again insert choice 1. I will get the output as stack is overflow. So I will select a second option, that is pop. Okay, or we'll get this is the program for stack using array. Then next is Polish notations. The process of writing the operators of an expression either before their operands or after them is called Polish notations. The main property of Polish notation is that the order in which operations are to be performed is ascertained by the position of the operators and operands in the expression. There are basically three types of notation for an expressions. First is prefix notation, second is postfix notation, and third is infix notation. So in prefix notation, if the operator symbols are placed before operands, then the expression is the prefix notation. And if the operator symbols are placed after the operands, then the expression is postfix notation. And the operator symbol is placed between operands, then the expression is infix notation. Suppose here the expression is written like this: a plus b. These these are the operands, and this is operator. The operator is written between two operands. Such notation is known as infix notation. The operator is written before the operands. that is written like this is known as prefix notation. The operator is written between two statements, that is two operands, is known as infix notation. The operator is written before two operands is known as prefix notation, and the operator is written after the operands is known as postfix notation. So here we should have to convert infix to postfix. Suppose the expression is written like this: a plus b into c, and value of a is equal to 4, b is equal to 3, and c is equal to 7. What is the exact answer of this expression? What is the exact answer of this expression? Tell me fast. A.
25.
How?
25.
25.
25. How?
First 3 into 7
One
and
minute,
then we have
1
to add
minute.
4.
4 plus 3 into 7. Then you have done this operation. Then you have done this operation. Okay. Is that correct?
Yes, sir.
Suppose instead
Yes,
of
sir.
this expression, I have written like this: a plus b. This whole expression has a bracket, then into 7. Into 7, that means c. Then you will get first solve this parenthesis, that is brackets, and then do the multiplication. So here need the parenthesis. So if you have given the parenthesis to these operands a and b, your answer is like this: 49. Okay, so we should have to learn how to convert from infix to postfix or prefix notations. So suppose the statement is given as here, here first is infix, then prefix, then postfix. Suppose first statement is a plus b. So first go as operator, then operands. In postfix, first operands, then operator. Then a statement like this: a plus b into c. So So here you should have to decide precedence first, which operation comes first, that is the multiplication. So here it should be bracket first. So the statement can be written like this: A plus B into C. So here one operand, here another operand. So first is for prefix, it can be written like this: plus A in bracket B into C, then plus A into BC. This is the prefix operation. Then for postfix, A B into C plus, that is A B C into, and then plus. Did you get, all of you? Hello? All the students, did you get?
Yes, sir.
Yes, sir.
Okay, similarly, we can see the operations like this. Here, bracket is one operand into B, then first multiplication, then minus sign, then ACB will solve. Suppose the statement like this: A minus C bracket, then multiplied by B. So this is one operand, this is another. So first multiplication, then A minus C, then B. Then next step, remove this bracket, A my multiplication, and then minus the AC, then B. This is prefix, this is infix, this is postfix. So for postfix, A minus C B into, that is AC minus B multiplied. This is postfix operation, this is prefix operation. Then next operation, in bracket of 1 minute. Hello? No problem. Suppose the infix expression here, infix, prefix, then postfix, a minus c, in bracket a minus c into b, this is infix. Okay, I want to convert in prefix. This is one operand, this is second operand. So remove middle operator as a first. So multiplied comes first. Then first operand, that is a bracket a minus c, and then second operand b. Then multiplication as it is. See here, middle operator as a first minus, then a, c, and b as it is. This is prefix. Did you get? Okay. Then for postfix, this operator after the operands, so a minus c as it is, then second operand b, then operator. Okay. Now first operands from this a, c, then operator minus, then b into as it is. Did you get? Hello? Then next example, so in first bracket a plus b divided by, in second bracket c minus, so here this is first operand, this is the second operand, then division comes first, then first operand a plus b, then second operand c minus d, then division. Here first operator plus, then two operands a b, then here operator, then two operands. Okay, so for postfix also, first two operands a plus b, this is first operand, then second operand c minus d, then operator. Then from this expression, two operands first a b plus, from this expression two operands first c d minus, then division. This is the postfix expression. All of you get? Hello? Okay. So these are the some examples of Polish notations in infix notation, prefix notation, and postfix notation. Then last point from this chapter, applications of stack. So stack is used for arithmetic expression. Stack is used for reverse to an entered string. Stack is used for recursion. Stack is used for Tower of Hanoi. Stack is used for interrupt handling. Stack is used for polish notations. Stack is used for interconversion between infix, postfix, and prefix expression. Stack is used for matching parentheses in an expression. Then next part from these Polish notations is infix to postfix expression. So Polish notation, that is conversion from infix to postfix. Suppose expression is written like this: a in bracket a plus b into c. In table format, it can be written as character then postfix string then operation stack then what is action is done, that is action. So here first character is opening bracket, so enter opening bracket, then postfix string is empty, initially it is empty position. Operation stack is insert in this stack, that is opening bracket, then action is push character into the stack, push character into stack. Then the second character is a, here the second character is a, so character a postfix string. Now a string is combination of all characters, but here the characters that means symbols, operators and operands, that is here a operation stack, that is opening bracket. Action is add character to postfix string. Here add character to postfix string. Then next insert character is plus, postfix a string is a, operation stack is opening bracket and plus sign. Then here push character into stack. Then next character is a b, postfix a string is a b, operation stack is opening bracket and plus sign. Then here action is add character to postfix string. Then insert next character, that is here closing parenthesis. So here insert next character is closing parenthesis. So here action is whenever you have inserted these closing parentheses, these parentheses, opening parentheses from this is removed. Whenever you insert closing parenthesis, then inserted, that is starting parenthesis, is removed from this tag, and so prefix string is a b, and here remaining character is plus, and now stack becomes empty. And here pop, whenever you have entered this closing character, closing parenthesis, then here action pop till opening parenthesis, till this opening parenthesis, and add possible, and add to prefix, add to postfix. Then enter multiplication sign. So here your postfix string is multiplication, that is a b plus, and go to the stack multiplication. Then here push character into the stack. Then enter variable, next variable c. So postfix string a b plus c. Then here again multiplication, then add character to postfix string. Then you will get here a b plus c into, then remove that, that is this becomes empty, and pop till stack becomes empty and add to postfix. Pop till stack becomes empty and add to postfix a string, and this is you will get postfix expression as a b plus c into, this is by using table, and here you should have an experiment conversion of infix operation to postfix operation by using stack. Okay, this program we will see in next lecture. If you have any query regarding today's lecture or previous lecture, please ask. Otherwise, write your roll numbers and leave the session.
Sir, can you send notes of this chapter?
Hello?
Hello, sir.